We shall stop at 10 o'clock because you have maybe other hours. So anyway, in this kind of problems, you actually have both types of exercises, free extrema and conditional extrema. For example, let's consider the function f of x and y equals logarithm of x squared plus y squared minus xy. On the set given here, x squared plus y squared less or equal than 16 and y greater or equal than 2. What that means is the unit disk, it's a disk of center 0 and radius 4. Yes. For example, here we have the point of coordinates 0, 4, and y greater than 2 means this. Yes, this is the straight line of equation y equals 2. So the set on which we want to find the extreme values of the function, it's this one. It's closed and bounded. So first, the first problem will be to take on the set d xy given by x squared plus y squared strictly less than 16 and y strictly greater than 2. That is an open set. And here we have a usual problem. Sorry, here it's a parenthesis, of free extrema. We compute the partial derivative of f. And now we need to solve the system. 2x minus y times x squared plus y squared equals 0, and 2y minus x times x squared plus y squared equals 0. Now, to solve the system, the simplest idea is to subtract the two equations. That is 2 times x minus 1. Here we have the common factor. If we put minus x squared plus y squared, it will be, if we take plus here, it will be x minus y equals 0. If we subtract the two equations, this is what we get. So x minus y times x squared plus y squared plus 2 equals 0. And obviously, this parenthesis cannot be 0. So consequently, x must be equal to y. Yes, so if x equals y, now it's 2x minus x at 3 minus x at 3 equals 0. Yes, because here it's, you understand, y equals x. So 2x minus 2x at 3 equals 0. That is 2x times 1 minus x squared equals 0. This will give us x1 equals 0, x2 equals 1, x3 equals minus 1. Yes? Please tell me if you got the same values for the system, the same solutions for the system. So we've got the points 0, 0, 1, 1, minus 1, minus 1. But attention, none of them belongs to D, because in D, y must be greater than 2. And as you can see here, y is 0, 1, and minus 1. So all these points are actually below the straight line y equals 2. Yes, is it clear what I'm trying to say? If you have any question, please, let's discuss. Okay, are there any questions? Maybe you found other solutions. Please tell me. Is it okay? Did you find the same solutions or not? Maybe it could be, there could be mistakes here. Now, the partial derivatives. Did you get the same values? No. It's okay, yes? Then, the system which gives us the critical points. Did you get the same? So the first equation, it is something like this. And if you eliminate the denominator, I think you get this one. And similarly, this one. And then here, subtract the two equations. And from here, we get that x must be equal to y, because this expression cannot be 0. X equals y means finally 0, 1, and -1, and x must be y. So we get these points, which are not inside our set, as you can see, because our set, it is this one, inside this one. But anyway, y must be greater than 2, and none of these values is greater than 2. Okay, so inside there are no candidates. Let's see on the border. Now, attention, the border means this. This one together with this one. Here we can consider two problems. One problem on this set, on this piece of a circle, and the other one when y equals 2, but attention, y equals 2 and x squared plus y squared equals 16, means actually x, if y equals 2, x squared equals plus 4, it's 16. So we get x squared equals 12. So it means x 1, 2 equals plus and minus 2 root of 3. And y equals 2. So actually, the we have two possibilities. First, when y equals 2, so here we are on this straight line, yes? So our function, in that case, will be a function of one single variable, f of x and 2 equals logarithm of x squared plus 4 minus 2x. And it's very simple to find the extrema of this function of one single variable. The other possibility is when x squared y plus y squared equals 16. Yes. That means on this piece of circle, and y must be greater or equal than 2. This is the problem we need to solve. This is not trivial, because the first one is trivial. It reduces to a function of one single variable to find the extrema here. In this case, we consider the Lagrange multipliers method, which is this one, plus lambda times x squared plus y squared minus 6 plus y squared minus 16. And here, and don't forget that y must be greater or equal than 2. And now here, you use the method of Lagrange multipliers. Compute the partial derivatives and so on. Yes. And don't forget, so it will be 2x. I just write the system, you solve it. Minus y plus 2 lambda x equals 0. 2y over x squared plus y squared minus x plus 2 lambda y equals 0. And of course, x squared plus y squared equals 16, and y greater or equal than 2, because we are on this circle, but attention, only that piece of the circle which is above the horizontal line y equals 2. Now, to solve this system, you can do it in the same way as before. So subtract the two equations. Yes, and then continue. Okay, so Thursday, we have the last lecture. We will have another lesson, implicit functions, and there will be another applications of local extrema, as you will see. Now, at the seminar, you will not have exercises from this last lesson, implicit functions, but at the lecture, we have enough time to solve several exercises. And also here, next week, also next week, we shall continue. We will have, so for the last lecture, I repeat, from Thursday, it will, what we do there, it will be at the exam, but without having problems, solve problems in the seminar, but there will be enough at the lecture and here at the rows. Anyway, at the lecture, we have enough time. If you have some other questions related to the exam or whatever. So we decided that our next lesson will be Wednesday, 9 o'clock in the evening. Is it okay for you? Not necessarily for you, because maybe there will be other colleagues which will be present. So I wrote on the Microsoft Teams that our next meeting will be Wednesday. If you prefer, but now we already announced it. So we leave it. And now tell me, the next week it will be already the session of examinations. Tell me if Monday, as today, Monday 9 o'clock or 8:30, let's say, is it okay for you?
Oh.
Yes or no?
We have an exam with our
We
group
have an exam.
on
Okay,
next Monday.
we can change it. Tell me for next week. I mean, for next week, instead of Monday, what in the morning? What would you prefer?
I think that Wednesday was great in the evening.
Yes, yes.
Now, this week it will be Wednesday 9 o'clock. But what about next week? Again Wednesday.
Yes, I think it's okay. Still Wednesday.
Wednesday 9 o'clock. Yes.
Yes.
And we need two data. So another one. So Wednesday in the evening. Yes, 9 o'clock is okay. Sorry. So Wednesday 9 o'clock in the evening. Okay. I mean for the next week. This week it's already stated. But also another day for next week.
Luni, dar mai pe seară?
Please.
Luni, dar mai pe seară.
Monday it is a little bit difficult.